Yeah, but when we found this one here, it was pretty clear. And these are soft-bodied animals. This is the mouth part, but even there's still more details. This is the gastrointestinal tract, which is still there. The ovarium here, and here you can see that it's producing an egg. And we also have several developmental stages of these nematodes. Here, single cell, several cells, and here an active, almost completely developed nematode inside. And we know from studies of model nematodes, at least those that have been studied well, that it takes about 800 minutes from the single cell state to the moment so here, it's actually from the egg. So what you're observing here is just a new nematode being born. Another animal associated with a gladiophyta is this little critter here. It's a trigonopod, spider-like animal, and it's sitting here inside the sporangium. Here we have a longitudinal section of the animal. It looks flattened, but it's simply imploded when it was in the silica-rich substance, because this is the original shape. This was definitely not a vegetarian. Mouse apparatus here. It was a real product, even though it was only a couple millimeters small, 5-6 millimeters or there. Here we have the same picture again. It's sitting in the sporangia, and this is not the only one there is. Other colleagues have observed this as well, and several theories have been proposed, varying from, well, inside the sporangia they were sitting nice and dry, or they were eating spores. No, they were not eating spores, because we already have seen it was not a vegetarian. Or he might have been hiding from other organisms, maybe, because here is the one, it's the overview, and here we have an unidentified larger animal, which is at least 2.5 centimeters long. But the real reason why they are there is this, these structures here. And if you look at the spider, here, it's sitting in the middle of something, browny stuff. If you look at that higher magnification, you see that these are coprolites. Coprolites consisting of skins of these mites, and the mites themselves are sitting on the inner layer of the sporangium, the tapetum, which is very rich in protein, because it forms the spores. And these are real suckers here with this typical mouth shape, but the sporangium wall is also infected by fungi, and it's known from mites that they can't digest it directly. These fungi are pre-digested the plant material, and these are the oldest mites, well, complete ones known. Again, some botany for the people who are not familiar with it. One of the great people in botany is Wilhelm Hofmeister, who published in the 1850s a study about the sex life of plants. And he discovered the so-called alternation of generations. That there was a haploid generation, which is shown here in dark blue background. And there is a diploid one with the light blue background. And when the spores are formed, a meiosis takes place, and you have to change to the other generation. What happens here in the master chair is what we know as the green moss plant, is a so-called gametophyte, and it has the antheridia and aphigonia, with the sperm cells, producing sperm cells here, with the egg cell here, and you know, all know what happens if you have an egg and a sperm cell, there's fertilization, and 1 plus 1 is 2, and then you have the diploid phasing. This gametophyte is a hydrophyte, often very small, not really something you immediately see. Sometimes they even live on the ground like this and this discovery by Hofmeister has changed a lot of things in botany. And let's see how that looks in the Rhynie Chert. Here are the sporangia pig-layer python. There we have spores formed in groups of 4, so-called tetrads. And spores typically have this tri-radial mark, seamless bands. And that's where they open here, and then the young gametophyte grows out. Here you see the first cell division, and then a number of successive cell divisions here. And finally, what you see also at the beginning, that already the very young gametophytes have these mycorrhizae. Here you see the albusters. And the plant depends on these mycorrhizae. Nowadays, about more than 95% of all plants, Ireland, have these mycorrhizae, and they need it. For instance, for water and nitrogen supply. But already the development is well established. And then here, this is the original spore. It grows out into a kind of trumpet-shaped thing, and with on the lower side is rhizoids again. For comparison the size, this is the remnant of the old spore, and then it has the upright axis, the vertical axis. Here we see them again, and then on the slightly flattened axis, you have these dark structures here, which are the antheridia. Here we see them again in greater detail. Then the remarkable thing is that the gametophytes on this plant have a vascular strand here. Here we see details of the tracheates. It has stomata. And this is one of the antheridia, and the small dots on there are the sperm cells. Here we see the higher magnification. Here, and what we see here is an antheridium that just bursts open and releases the sperm cells. Wow. So, very fast preservation, at least in my opinion. But there are some colleagues who think that they need about 6 months to preserve this stuff. Where you have the male ones, the antheridials should have female ones, the aphigonia, and they are shown here. Those dark structures up here, here you look into it, here we see the stomata, and this is the longitudinal section, and this is where the egg cell is situated. So, with this information, you can reconstruct the entire reproduction of this plant. And this is really unique. At least, well, we know several other ones from the Rhynie Chert right now. But in this amount of detail is not really known in the fossil record. We also have cyanotherial mats. These structures here, these are aquatic, but we also have stratified, and they are probably subaerial. And we suggest, because they would have been a little slimy, that the spores need them to germinate. And what we see indeed are spores in there. It's not, of course, not only one thing that we find in there. So fungal hyphae, we find coprolites, these things there, and we also find young gametophytes in there. And this plant, the Gleophyton, it had no underground parts. It could live on hard substrates like cinder, but as long as there was kind of microbial mat, it could develop. Here we see things that we interpret as gas bubbles. We come back to that later on. So, summarizing this plant, the Gleophyton, all the organisms are shown, fungi, fragment spider, nematodes, crustaceans are all associated with this plant. And that's how we try to unravel the ecology of the Rhynie Chert. Doing it for every plant as good as possible. Of course, I'm not going to show you every plant in so much detail, because that would take much too long. But this is the kind of way we are working. Another class from the Rhynie Chert is Rhynie. That's very similar to the Gleophyton. Originally was placed in the same genus, but later on they separated them, but I'm not so sure whether that's really justified. But anyhow, it forms these very dense stems. You also see here these, you can already recognize the dark green here, the mycorrhizae. But it also forms these bulbous structures here. Here you see one of them, synchrotron X-ray. Sporangia are relatively rare, and these are the tracheates. These structures develop rhizoids, and we now assume that they use asexual reproduction. This is a very informative specimen from the Aberdeen collection, where we see from the bottom to the top it's about 25 centimeters. We see the upright stems, we see the bifurcated. There you have an idea how large these plants were, about 20 centimeters, 45 maybe. And you see these dark lines here. Here's one, here's one. And those are microbial mats. And then you see these things here. These strange round things. And these are gas bubbles. And you have to imagine that your small pond standing water, microbial mat develops on the surface. Below there's gases are getting off, probably methane. But they can't get to the surface because we have this methane that's simply trapped in there. In the meanwhile, we also know the gametophytes of this Rhynie plant. Originally, Rhynie has even been interpreted as the gametophyte of the Gleophyton, but when we found the real ones, there was no question anymore. And this is really an in-situ stem. And here we have, this is one of these color axes that we showed just in a little bit more detail here. Here are the Antheridia, here's Machidonia. Here. And this is the basal part, spore, remnants of the spore, and here are the rhizoids. They're also lying on such a microbial mat. And again here, these are Antheridia, and again we have a specimen that's just as sperm is being released. This is Archegonium, and this is Archegonium, this is one, and this is a very special section here, because we think that this is the so-called gametophyte sporophyte junction. We see here an axis of relatively small cells. We know that it's gametophytes because there's an Archegonium there, and here the one with very large cells, the axis with very large cells, simply appear to grow out of that one. And things like this are really very difficult to document and living terrestrials. Another type of plant is Dotia. It does not have these apical spindle-like sporangia, sporangia that are attached laterally. It has underground parts, rhizomatic axes, and it definitely has clonal growth. This reconstruction was made by making a large number of sections from a block, scanning them in, and putting them into a computer, and modeling the thing. It was done in France and Montpellier, with a postdoc from Montpellier who did this work. She came up with this one, and this is really nice. This is an axis here, an underground axis, rhizomatic axis, and here we see these tracheates here, the rhizoids, and we're going to look at that a little bit more in detail. One of the rhizoids contains also ectoparasite. Not all these fungi are so harmless. Some are really parasitic. We're going to see a couple of very nice examples of this. But there are also macrorhizae, which are these hyphae here. You might even see very thin, two very thin lines inside this rhizoid. These are also the macrorhizae. And then strange roundish things, and these are also fungi, but those are very aggressive ones. Those are real parasitic. Here we have them in detail, these things here. And the host reaction of the plant is that it forms additional cell wall material to encrust those fungi, to strengthen the cell walls, and to encrust the hyphae, so that it forms a natural dam that separates the infected tissue from the still healthy, uninfected tissue. The fate of the infected tissues you see here cells simply disappear. And, well, the measure of the plant in this case, what we see here, was not very effective, because if we enlarge this part here, we see this, that the fungi are already penetrating still healthy tissues. So another nice example of interactions between three different types of fungi in a single plant. We also know the aminophyte, this one, at least the one that has the antheridia, it's pretty complex in its morphology, much more complex than the simply slightly flattened axis we have seen before. And there is another plant with underground parts forming this rhizomatic axis, which are a little bit bulbous, like these structures here and here. Reconstruction, you see these potato-like things. It has a pretty well developed vesicle strand, and the sporangia are very typical. They always occur in groups of two. Here is the strand leading to the one, and this is the other, but comes a little bit of bleed. And it has a central structure consisting of sterile tissue, and that's nowadays only known from mosses, but this is definitely not a moss. Here we have the spore still in tetrads, here we have the two, here we have the spore, a single one, petrologist will definitely recognize it in fungus varieties. Here we have one that just germinates with the aminophyte comes up. And also here we have the Achigonia. The Achigonia, this one is seen from above. The antheridia are not so well preserved, but here they are. And then the most complex plants from the Rhynie Chert, about 40-45 centimeters in height. So this one, terrestrial, looks like a modern club moss, and it's indeed like offset. Here we have two longitudinal sections, here through the very nicely shown the apex of an axis. It has a very well-developed vascular strand, and we'll see it in detail in the next slide. It has these leafy structures, but these leafy structures don't have a vascular strand. If you make a cross-section, you see this here. This is the vascular strand. It's cross star-shaped, and that's why it's called terrestrial, the star-shaped one. And these are the aerial axes, and you see that vascular strands are given up, but they end just in the periphery of the stem before they will enter the leaf. These are the tracheates, a longitudinal section, and these are the rhizomatic axes that we're going to see in detail on the next slides. The aerial axis, here you see a couple of sections through upright standing aerial section that is top and then go further down, and they often have these so-called arrestant axes that are formed initially but do not develop. And the detail of the structure you see here. The typical stomata, these are the underground axes. This plant, well, you may call them roots. They are not real roots in the biological sense, in the sense that they lack a root cap, but they can go up to 20 centimeters deep into the substrate, making this plant less dependent on permanently humid conditions. And here, in this one, you see it even pushing down into the sandy soil. We recently described also the reproductive structures. There were a few isolated sporangia known, but now we have a couple of axes that with strongly sporangia attached, a large number of sporangia attached. They consist of two balls, and they're very convex, much more than drawn here. There's also construction, and depending on how you come, they may even up end up with these alien-like structures. And here we have another fertile axis. This is the apex. This is the sporangium here. Here's the same thing, same axis, just the next cut. And you see, there are no vascular strands in the leaves. But the sporangia have a vascular strand. This is sporangium. Most of them are empty, but this one still contains spores. Here we have the spores. We have a very nice adhesive mechanism, how they open. And this is one ball, and this is the other one. And here we have the spores in situ inside the sporangium. And this is a cross-section through extrastructural, typical star cross-shaped vascular strand. And you see all these tiny dots here. And some of you may have seen part of this slide before. I think this morning or yesterday, I'm not sure. But these are ascomycetes, the oldest ones. We know. Ascomycetes are nowadays very widespread, some very dangerous fungi.